Okay, I started in on this, and so basically the idea is I already told you non-conservative forces are things where it's path dependent, like friction. So like no matter what you do, I didn't really say path dependent, but that's what I think I said that in another video. But anyway, non-conservative forces is basically friction in real life. Now in physics, since it's technically a physics class, really they could be anything, and when you go out into space and quantum thingies, all kinds of other things can turn out to be non-conservative forces, and there is a way to figure this out, besides just looking and going, it's friction, it's fine, because I usually teach engineers, and where engineers are like, derp, 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 look up stuff in table, derp, 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 it's fine, let's just move on and design the rocket to do stuff, and that's when rockets explode. So we do have to have some respect for the fact that physics exists. Okay, so the idea is that there's some math that shows this exact differential has to match, for something to be conservative, for this to come out to zero. And it's like, so we blah, 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 and then there's this, and so for this to be true, then this has to be true. And so I went to ChatGPT because I'm lazy, and I was like, well, why does that have to be true? And it was like, oh, well, it's this, and clearly we have this vector field, and the condition for an exact differential is this. Now, I do remember doing this in differential equations, but I don't think y'all have had differential equations yet, so that's not helpful. And I'm like, well, I can't just be like, so guys, clearly, if you remember from diffie-q, so I was like, well, maybe it'll be like a quick, like little example about like why this holds in physics. And then I was like, yeah, but it says from multivariable calculus, where does that come from? It's like, oh, well, this comes in from like basically the definition of calculus. So for going into, this is also, again, something we do in diffie-q and blah, 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 blah. So where I'm going with this is there's like a whole lot of math that goes behind this. And since this isn't a math class, this is a physics class. I mean, in a physics class, it's like you should clearly understand the math already because all physicists know all math. From an engineering perspective, it's fine, it's friction. From a math perspective, go look at it, it's really cool. And then for the rest of us, just knowing how to handle this. So basically the idea is if you take the derivative of the x part with respect to y and the y part with respect to x, if they come out to be equal, then it's considered a conservative force. I think there's also something to do with a cross product in there. Honestly, it's been a while. I don't 100% remember. So, for example, if we had a force that was given by, and I hate how I know why they put the units in there, but I'm just going to do it like this. I hat plus 10x j hat. And I want to know, is this a conservative force? Well, in order to check to see if it's a conservative force, then I would be like, well, ddx of that, and then ddy of this, and are they equal? Oh, no, ddy, sorry, I just literally wrote it the wrong way. ddx of the... No, I had it right. Okay, I'm going to rewrite this because I'm freaking myself out. I'm going to not skip any steps. Okay. I'm going to write ddy of f of x, dy of f of x, or f sub x. Does that equal d f sub y of dx? There we go, ddx. Okay, so dy and the f of x term is 5y. Does that equal, and then the y term is 10x. Okay, and then clearly 5 is not equal to 10, so non-conservative. Okay, and this is just a great way for me to ask you calculus questions in this class. So, if I'm looking at these to see, so I got a ddy, the first one, and ddx, the second one. So I just need to keep remembering that. So ddy the first one and ddx the second one, and are these the same? Hi, kitty. That was a weird cat sneeze. All right, so I'm going to ddy axy cubed. Does that equal the ddx of ayx cubed? I don't know. Well, if I ddy, the a and the x are constant. So 3axy squared is that equal to 3ay x squared? Well, no. It's not the same. Is it the same? Is it supposed to be the same? No, non-conservative. Okay, good. I got that one right. Whew. Okay. Let's do the next one, just because I feel like I need to practice taking differentials of polynomials somehow. So I've got d dy of the first one, d dy of the first one. Oh, I know what I'm thinking. This does end up being a cross product when you do this in 3 dimensions. Okay, yeah, you'll thank me later. Don't do this right now in 3 dimensions. It's terrible. That's why I was confused. I was like, I don't remember this. It's like, yeah, because the last class I took this in, we did it in 3 dimensions because we're super cool. Oops. That's what I was thinking. Okay, so did I write that correctly? Yeah, okay. So d dy, so that's 2y over x. Is that equal to, okay, 2y, and I'm going to write this again because natural log of x over b. So if I take the derivative of a natural log, it's 1 over x, right? I think, which actually looks like it's going to make sense. So 2y, the derivative of natural log, what's the derivative of natural log of x over b? Okay, I feel like it's just going to be 1 over x, but I'm going to write this out off to the side because this is where my brain stops working. And I'm basically trying to show you what to do when your brain stops working. Okay, so I want to find the d dx of this. And I know there's something, and I just can't remember what it is. So I have to come up with a different way to solve it. Now, I know that the loggy thingies, I can rewrite this as natural log of x minus natural log of b. Like that. Remember? Remember that was a thing? Man, I hope that's a thing. Otherwise, I'm going to be really embarrassed later. Okay, so now I can d dx each one individually. And the d dx of ln x is 1 over x, and the d dx of a constant is 0. So that is just 1 over x. Okay, I had it right. I was just freaking out a little bit because that b was just messing with me. So I went out to the side, I figured it out, and so are these the same? I think they are. Are you going to give me the same thing here? Come here, girl. Ah! Yay, they're the same. Well, you can't tell. 2y over x equals 2y over x. Yay! Okay, so stuff like that. Oh, this next one is kind of uglier, so just to make sure we know how to do that one, also because I just like taking derivatives, d dy of the first one, ax x squared plus y squared. Is that equal to d dx a y, you can't see what I'm writing, x squared plus y squared. Okay, let's do this. Whee! Meow, 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 meow. Okay, science! Okay, so this is getting d dy'd, and this is getting d dx'd. Okay, for the purposes of making this less annoying, I'm going to pull out the ax, and I hate taking derivatives, things like that. So I'm going to d dy the x squared plus y squared to the negative 1. Does that equal a y times d dx of x squared plus y squared to the negative 1? I'm going to be dead honest. I never memorize my quotient rule, so I always do this. I know it's like Heidi Low and Lodi something. I don't care. So I'm just going to do this. So I have ax times negative 1 times x squared plus y squared to the negative 2, and then the d dy of the inside. I'm just going to write this out so that you know what's happening. X squared plus y squared. So I'm taking the derivative of the inside. Same thing here. Negative 1, x squared plus y squared. You're like, it's just way easier to memorize the quotient rule. And you know what? You're probably right. But, you know, I'm just not going to. And you can't make me. Okay. So we've got that. I have negative ax over x squared plus y squared squared times the d dy of that, so times 2y. does that equal negative ay over x squared plus y squared squared times 2x? It does. Hot damn. That's amazing. So, yay, they're conservative. Let's hope that's the right answer. Yes, again, conservative. Awesome. Okay, so now you can kind of get an idea of how physicists do this in the real world when you're not just like, I don't care, I'm just trying to solve problems, and these physicists and their math are always getting in the way. So, pretty good ideas there to determine if the forces are conservative or not. That was fun. Yay!